Alright, let's do question 7, which is again another diffusion equation question. Alright, so this is a question, and again I've written the essential information down here. So it's a diffusion equation, again 2 boundary conditions and 1 initial condition. Alright, so since it's the diffusion equation, we start with the general solution for diffusion equation, which I've just copied straight from the formula sheet. So let me call this equation 1. So first step, I'm going to put in the first boundary condition, right? So I'm going to put boundary condition 1, which tells me that big T at x equals to 0 is 0. Okay, I put it into equation 1. Okay, right, and that gives me, so I just put x equals to 0 here, here, and here. That gives me C plus 0D plus A cos 0 is just A, B sine 0 is just 0, so it's just left with this. This is equals to 0. Okay, so again from here you can tell that your C must be 0 and your A must be 0, right? That's the only way to make this left hand side here to be 0 regardless of what T is, okay, regardless of the time. Like so with C equals to 0 and A equals to 0, alright, so we have C is 0 now, A is 0 now, okay. So your equation 1, which is your solution, can now be updated. Okay. T, big T is now just dx plus b sine omega x e to the power minus k omega squared t. Right, so this is my updated solution, which I'm going to call 2. Right, so I've used that boundary condition 1. I'm going to start using boundary condition 2. Right, to use boundary condition 2, I need dt dx. So from 2, I can find what my dt dx is. Okay, so differentiate with respect to x, dx just becomes d, and sine omega x just becomes omega cos omega x e to the power minus k omega squared small t. Alright, so that is d big T dx. So now I'm ready to put boundary condition 2, to use boundary condition 2. So I'm going to put boundary condition 2, which is dt dx at x equals to pi. Okay, this has to be 0. Put this into equation 3. Okay, and that would give me, alright, so I'm going to put x here as pi, so x becomes pi. Okay, so I have d plus omega b cos pi omega, right? X is pi now, times e to the power minus k omega squared t. Now this has to be equals to 0. Okay, so again this has to be 0 for all values of t, values of small t. So this then means that I have to have d here has to be 0. Alright, and again we don't want to choose b to be 0, because if you choose d to be 0 and then d to be 0 and b to be 0, there's nothing left in your solution. So instead we choose cos pi omega to be 0. Okay, so cos pi omega equals to 0 means, again, your angle here, pi omega, must be an odd number of pi over 2. So again, this is how you can write odd number for pi over 2. 2r plus 1 always gives you an odd number, times pi over 2, alright? And your r starts from 0, right? Okay, you can see that when r is 0, the angle pi omega is just pi over 2, and cos of pi over 2 is 0. When r is 1, you get 2 times 1 plus 1, that is 3 times pi over 2, right? So when omega pi is 3 pi over 2, okay, 3 pi over 2, you cosine it, it will be 0. Okay, so you can check that all these values of r gives you an angle of here, pi omega, that when you cosine it, will give you 0. Okay, so I'm going to put all this information, d equals to 0, and okay, sorry, one more step first. So this now tells me my omega, so I bring the pi over, it's just 2r plus 1 over 2, right? The pi cancels out. Okay, so I'm going to put all, so 2, 3, and so on. Okay, so I'm going to put this information, d equals to 0, and omega equals to 2r plus 1 over 2. Okay, I'm going to put it into my updated solution, which is equation 2. Okay, and update it again. So my equation, my solution, updated solution 2 becomes okay. So d is 0 already, so no more d. Okay, I'm just left with b sine, okay, and omega here is 2r plus 1 over 2. So with 2r plus 1 over 2x e to the power minus k 2r plus 1 over 2 square, right, omega, right, times t, right? So again, your r can take on the values of 0, 1, 2, 3, and all the way up to infinity. So the value of r we take is everything. Okay, so we sum up r from 0 to infinity, and each value of r will have its own coefficient b. So we do a b sub r. Right, so this now becomes my most updated solution, equation 4. So the only thing left to do now is to find out what BR is. So the only thing left for us to use is the initial condition. Okay? Right. So I'm going to put the initial condition into my most updated solution, which is equation 4. Okay, so I'm going to put the initial condition. Okay, so initial condition means what is the big T at time equals to 0. Okay. So at time equals to 0, my big T is 100 sine x over 2. So I put this into my most updated solution, which is equation 4. Okay, so what does this give me? So I'm just going to put t to be 0 here. Okay, so this just gives me BR sine 2r plus 1 over 2 x e to the power of t is 0 here, so it's e to the power of 0. Okay, and this must be equals to 100 sine x over 2. Okay, so again, you can see that e to the power 0 is 1. Okay, now this is not exactly a sine series, be careful, okay, because sine series you just have a sine r pi x over L. This is not in that form. R pi x over L is not, okay. Alright, so what you need to do is you need to expand this out. Okay, you need to expand this out. Okay, so we do it by inspection. Okay, so I'm going to expand this out. And look for matching terms. Okay, so we start with r equals to 0, so we have b 0 sine. Okay, so when r is 0 is just x over 2. Okay, then you have when r is 1, you have b 1 sine. Okay, when r is equals to 1, this just gives me 3 over 2. So 3 over 2 times x, and then when this r is 2, you get b2 sine 2 times 2 plus 1, that would be 5, so 5 over 2x, and so on, right? So all this must then, the left hand side expands out to this, it has to be equals to the right hand side, which is 100 sine x over 2. Okay, so again you can see that this is the matching term, the first one. Okay, so you can then see that your b naught must be 100. Okay, and all your other b's, your b1, your b2, your b3, and so on, they are all equal to 0. Okay, so now all you need to do is to put all these values of your coefficients back into equation form. Right? Back into equation form. Right? So you have many values of you have many BR values. Okay, but the only one that's not 0 is B0. The rest of the B's are 0. So therefore your solution 4, it becomes, okay, right, you only have a non-zero B0 term, the rest are all 0. So you just put B0, okay, actually don't even need to put B0, straight away put B0 as 100, so it's just 100, okay, B0 is 100, sine, okay, so r is 0, so this is just x over 2 e minus k, so again r is 1 here, so this becomes half squared, sorry, r is 0 here, not 1 here, r is 0 here, so it's half squared times t. Right? So this is your solution, 100 sine x over 2 e to the power minus k over 4t.